I'm Riley Seitz.
And I'm Ashley Bold.
And for our Do Something and Report It project, we went to the Red Wing steam plant. And right now we're in the control room where I'm guessing they control all the machines and all that good stuff. But yeah, we're going to show you around the plant.
My name's Joe Linder, lead plant equipment operator for the Red Wing steam plant. We're in the control center here. We're going to try to give a little tour, demonstration how stuff works. Basically what we're doing is taking municipal waste, processing it, and then transporting it to this facility. And we run it through a series of conveyors, bends, boilers, stuff like that. Burn it to make steam to turn generators for our turbines for the generation. And that's kind of the whole thing in a nutshell. This room here is the control center basically. We can control all the equipment from this location. Brad Marks, the operator, he fires the units and controls the truck unloading, all the fuel coming into the plant. He keeps an eye on steam flows, electrical flows, stuff like that from this center. We can, as you can see with the cameras and monitors, that we can basically watch everything in the plant. So here, on the center part here is basically the boiler controls. He can actually speed them up, slow them down, whatever he needs to do with them. Any alarms that come in, like feeders that stop or whatever, he can see what the problem is here between Troy Halverson and myself. We go over and take care of any issues that are out there. We have the back wall here, you can see we got all of our electrical stuff here for like our turbines and our generators, so we can roll our turbines up and bring generators up to speed, sync them in to go onto the grid, so we lock in through the subyard, stuff like that. We have all of our banks and we switch our electrical controls so that we're either taking it right off the generators and supplying our plant, or we're running it out through the subyard and bringing it back into the plant, depending on how we want to set it up.
Alright.
Okay.
So basically, that's kind of what the control room does.
Okay.
Okay, we have just some main questions. What are the most common things that you burn?
Like what's in the municipal waste? Just like everything?
Yeah, our garbage is processed in a facility in Newport. It's called RRT, I believe. Anyway, they get residential home garbage in, they get construction demolition in, and they run it through a process up there that basically shreds it, separates the metal, so we get plastics, 2x4s, tennis shoes, clothing, just anything you can possibly imagine.
Anything you can burn.
Comes through there except for medical waste. They're not allowed to process that, and we're not allowed to burn it because of the possibilities of infections and stuff like that with bloodborne pathogens and stuff like that. So we don't see any of that. We might see, like a few oxygen forms off the 70 or oxygen bottles for people, but that's about all we ever get down here.
Yeah. Okay.
Where does the energy go that is produced here?
That's basically what we're doing is we'll produce it. We send it out to our subyard. And out in the subyard we have different transmission lines that go out of there. And our I call it system out, but it would be our transmission department, distribution department. They kind of control where they're sending, what breakers they're closing, and where they're sending it to, what lines they're feeding, and stuff like that. We're basically just putting power onto the grid to hold line voltage up on this end, because we're kind of on the end of the system, so we start sagging a little bit more. So that's mainly our main purpose is to help hold that line voltage and stuff.
We've learned about the system in our class so far, so yeah, that makes sense.
So is there like a difference in price between like this energy versus like nuclear power energy?
Yes, there is. And I don't know the numbers right off. I can look them up.
Yeah.
I mean, I've got them on a form in here. Coal or average cost is probably around $20 to $25 per megawatt.
Yeah.
Let's see, we got Prairie Island here at 5.18 cents a kilowatt. We got Monty at $6.09. We've got the Red Wing generation here. We're at $3.28 a megawatt, and yeah, right around $3 for us to produce it for the cost of the fuel coming in.
Okay.
So, now that's probably not total cost because you got wages and
Yeah.
you know all kinds of stuff like
Little
that. I'm
things
sure
to
that
take
gets
care
in here, but these are just fuel expenditures for us that we can look at, and it tells us what kind of loads and stuff we have on this system. Like the system right now, we're putting 5,126 megawatts out onto the system right now, which is, that's quite a bit of power.
Yeah. Yeah.
Is the plant running all the time?
Well, we run, we try to run 24/7. I mean, we don't. I mean, there's shutdowns, there's outages, there's unexpected breakdowns, you know, we have to shut down, take them offline.
Yep.
The plan is to run, 7 days a week, 24 hours a day.
Okay.
And then we have like 3 outages a year where we actually shut the plant down, go in and just repair, clean everything, put in any new technology that come up. Because the technology is
Always changing.
always advancing
Yep.
in this
Yep.
stuff, especially in the emissions department. We're always doing a lot of stuff there, trying to keep
Keep
the
it
emissions
cleaner.
right downtown.
Yep.
We've got them down pretty low right now. And then we have 2 cleaning outages. Basically, they're like a week long. We shut both units down. We want to clean them all up. And if there's any little maintenance stuff, we get that done.
Yeah.
Back up and online and go again.
All right.
It's
These are all the emissions that are being put out by the plant.
continuous emissions monitoring system. That's what we run by.
There.
Right now we are in between the bag house and the actual power plant itself, and we are going to go to the start of the process and check out where all the garbage comes from.
I guess the bag house is where they control all the emissions. So yeah, we're gonna go check out the
This
rest
is
of
our
it.
sub yard where we send all the power off the generators. It ends up going through here through our 6, 9, 13, 8s, 12, 5s, all the different voltage ratings, and it's all broke down through there and it's sent out on distribution lines to the city of Red Wing and Lake City and Rock Creek, and Spring Creek, and just all the different lines. And just where it's sent. Well, we have a central dispatch system up in Minneapolis at 414 that actually they have control of all its equipment through the phone lines and computers and stuff like that, so they can direct it wherever they want it to go and stuff.
All right. Call everything. Okay, go for it.
These are the semis that haul the garbage here, mostly from the cities, but they transfer it to the cities to get chopped up and
You'll see more stuff like orange peeling rinds or like a banana skin or something like that, but it goes through quite a process up there with their flail mills and air knives and stuff that really destroys stuff. I mean, if you look at the garbage, there's all kinds of stuff. A couple balls made it all the way
Soccer
through.
ball, football. What else can you find?
You can see what
So
what
many
actually what
treats.
we're burning and stuff as far as that goes. This barn will hold
chip
about
bag.
There's food, clothes, socks, plastic,
jugs are a big one.
little baby Crocs, French fries, pretty much everything.
This stuff's supposed to be shredded to a standard size of like less than 6 inches, and which you can see it don't always
Doesn't
get that
work,
small.
yeah.
But our system is big enough to handle it. So discharges all that garbage into that yellow and maroon chute there,
Yep.
which drops it onto a transfer belt. We can show you that. With all that garbage now, as it went up that conveyor, it's dropping into here now. So it drops into here on this traveling belt. This belt's going to run it all the way to the top, which conveyor we looked at on the incline.
Yep.
Coming up here, dumping into that chute. And we're going to feed it into some storage bins downstairs. stacks are attached to one of the boilers. And all the air that we're forcing through that boiler will get drawn out, pushed up these stacks after it goes through our emission control system.
Okay, go.
To get, right now we're burning 100% RDF. So if you have a cold boiler, to get to that point, we use natural gas as the secondary fuel. And that's what we use to heat the boilers to the 600 pounds of pressure, the 700 degrees steam, so we can run our generators. When we get to that point in time, then we start bringing our generators in, which is another step in the process. It's an hour and 15 minutes to get them warmed up and put online. And then after that, then we actually induce the RDF with the natural gas until the RDF gets burning. And we go down, we can look on the grades.
And what does RDF stand for?
Refuge Derived Fuel.
Okay, and that's all the garbage?
That's basically the garbage.
All
That's
right.
its name.
Perfect.
So,
all right.
So then we induce the RDF. Once we get that burning and get our grates stabilized, get a good fire, we actually take the natural gas out. We shut the gas off, and we basically run 100% RDF. And we have introduced wood chips now. They have a lot of the, development companies or whatever that are actually, when they clear an area of trees, they have them shredded. They actually shred them and get rid of them.
Yeah.
Because otherwise, what are you going to do with it? Well, a couple of them have contacted us now, and they're delivering it here. We're mixing wood chips with it now at periodic times to help them guys get rid of it, and it's fuel for us. And it's shredded down pretty good, and it actually burns really good with it. We were up on the front, I showed you that melt that comes up.
Yeah.
And I showed her a dislocate. What it's doing is it's dropping down in here right now. That's what you hear falling.
Yep.
Garbage.
All the garbage goes down that chute.
That's coming down in what we call our distribution conveyor.
Okay.
Nicknamed it the DC, of course, but basically, on this conveyor, you're standing on one of the slide gates right now that open and close it. You can't dump us in there. Don't worry, we're standing on the outside. But there's 4 of these gates, one for each bed. Basically what we're doing, dump that garbage in here, and then allowing it to travel the length of this thing. It will eventually, the conveyor will run empty because it comes to the last bend and it makes, the chain comes back around to make it loop. You do me a favor and open metering gun gate 11. I'm just letting them open so you get an idea how it works. So now, it's just basically filling into here. And it'll fill this bend, to whatever desired level before the computer will actually close the gate.
So just use the computer to open a gate. Now the garbage is switching directions.
This is that bend we were filling, and if you look in here now, there's 3 sets of screws in here. They're big auger screws. They're slowly turning here. I don't know if you can see very good or not. But what that's doing now is that's feeding all this garbage out the south end of this vessel.
Okay.
And then it's going to drop into a couple, 3-4 chutes downstairs, we'll see. And that's what's actually going to let the fuel get to the boiler to be ignited. Gives you a good idea what's going on in here. If you look in here, you can actually see garbage is actually going down through here. All of them are doing the same thing. See, now if you look in here, you can see the piles of garbage that are burning now and how stuff is actually falling back more into the center of it. Warm, isn't it?
It's hot.
And as it burns, as it completes its combustion, it basically turns into this ash that we're seeing fall off the grate. That's our bottom ash.
That's the bottom ash flying. There you go. Right.
This is the bottom ash part. Fine particles over like that, and we can collect it here to pull with our bottom ash so it's landfilled properly. So there's a lot of add-on accessories to these plants to help clean everything up. And that's the main thing we're doing, is we're getting rid of the human garbage and waste out there that we've been producing for how many years. Well, now we're making something out of it. It's just a big square vessel full of water. We drop the ash in there, and then there's a drag chain. You can see it on the very bottom. The drag chain's going that way right now. And you just go down and you loop from the back, all the ash and drag it out. Comes off the top of the boiler where I showed you. It ends up coming down through this steam line here, this main steam line, and it's fed into the bottom where turbine here through the steam shaft, so we can control the speeds of our turbines and stuff. These are like throttle valves, so we can slow it down, speed it up, whatever. Spin this at 3,600 RPM, steam pressure. At that point, steam comes through the generator. It goes through a series of vanes, big round disc turbines, and the pressure keeps dropping, and as it does, he loses power. So what we did, we got a condenser on the bottom that's running cold water through it, through tube. As steam hits that cold water, condenses, it comes back upstairs, feed it right back to the boiler, feed her up, bring her back and go. If we do that, the turbine is tied right to the generator. There's no gear reducer or anything here. Some of them, I ran some that have a reducer in between them. This one don't, it's got red Prairie Island reducer. All it is generator sitting here is spinning just a big reverse motor, so to speak. Instead of using the power we're creating. Now when you really get into the steam engineering part of all this stuff, this steam gets too hot for us to run for our generator. So now we got to de-superheat it. So we actually have lines that are with spray nozzles in them to cool that steam temperature down enough so it stays at steam, but still cool enough so it's not going to hurt our equipment. So, I mean, you get into a lot more of it. You know, it's just, we're actually using the feed water, the hot feed water that we're putting to the boilers, which is at, I can go back and look, but I'm figuring it's running right around 238 degrees. We're actually taking a tap line off that feed water line to a desupermeter, so we're spraying like 240 degree water right into the steam to bring it down from the 700 to, or if it's over 700, to bring it down to the 700. Because we can heat it up to, you know, however high you really want to go if you really want to start playing around with it, you know.
After touring the steam plant in Red Wing, we made sure to do some research on our own to obtain a little more information on waste to energy and the pros and cons of using refuge-derived fuels to produce electricity to go on the grid. In contrast to the article we were given to read that argued against the use of waste to energy, our own research provided more positive benefits than negative. Using waste to energy provides an opportunity for energy reclamation. There's an 80 to 85% waste reduction in the volume of waste and a reduction of methane emissions due to the fact that waste doesn't sit in a landfill to decompose. It also provides a long-term security of waste handling by decreasing the amount of landfill usage.
Many are concerned about the emissions that are released from waste-to-energy plants, but dioxin and furan emissions have been significantly lessened by advances in emission control designs. When we toured the steam plant, our tour guide also explained to us the process of using baghouse filters to remove fine particles from the gases. Although advances have been taken to reduce the harmful effects of waste to energy, the process still provides the least amount of energy to the grid. There are many other methods and technologies that are available that produce significantly higher amounts of energy. As consumers of electricity, we should all be educating ourselves on the environmental aspects of different energy production technologies. Whether it is waste-to-energy plants, coal-burning plants, or nuclear power plants, each form of production has their own benefits and downfalls in regards to efficiency, environmental friendliness, cost, and many other comparable factors.